Good day everyone. So today we will discuss another grouping system which is called positional system. So positional system is an old system used by our ancient people before. In the year 3000 BC, Sumerian number system that would later inspire the Babylonian number system is created. The Babylonian system will be the first number system to use the positional system to describe numbers. So this system is the beginning of the history of our system, which is also a positional system. So as we go through deeper to our discussion about positional system, we will understand what is positional system all about. But before that, we will define first what is positional system means. So positional system is a numeral system in which the contribution of a digit to the value of a number is the product of the value of the digit by a factor determined by the position of the digit. So the definition is most confusing or confusing. So I have here an illustration to understand the definition of the positional system. So from the number 1125, so I have here, as you can see, we have position. So from the right, 5, 2, 1, going to left, so plus. For the third position is 1. Then digits, so the digits are 1, 2, 1, 1, 2, and 5. Then as you can see, the subtype, so it is what we call radix or bases. So because positional system use bases to compute or to convert number. So as we go to, we will understand what is a basis or radix all about. For that, we discuss first one by one the components of this illustration. So first is the digits and numerals. A digit is what is used as a positional place value notation, and a numeral is one or more digits. Today, most common digits are the decimal digits 0 up to 9. So like for example, in the number 12, so the digits are 1 and 2. And the distinction between a digit and a numeral is most pronounced in the context of number base. So understand. So next is radix point or base. So the notation can be extended into the negative exponent of the base b. Thereby, the so-called radix point mostly is used as a separator of the position with non-negative from those with negative exponents. So to understand further, the base of the numeral system. In the mathematical numeral system, the base or radix is usually the number of unique digits, including 0, that a positional numeral system uses to represent numbers. So for example, for the decimal system, the radix is 10 because it uses the digits from 0 through 9. When a number hits 9, that next number will not be another different symbol but a 1 followed by 0. And in binary, the radix is 2, since after it hits 1 instead of 2, it followed by 10, by 11, and by 100. The highest symbol of a positional numeral system usually has the value 1 so than the value of the base of that numeral system. For example, in the binary system, the base is 2, so the highest possible number or digit is 1, because based on the definition, 1 less than the value of the base of the numeral system. So it is octal or it has base. So the highest possible digit is 7 because the 0 is included and it starts with 0 to 7. So the standard positional numeral system differ from one another only in the base they use. So it depends upon the base that we use, or base 2 up to base 16. So the base is an integer that is greater than 1 or less than -1, since a radix of 0 would not have any digit and radix of 1 would only have a 0 digit, negative bases are rarely used. In a system with a negative radix, number may have many different possible representations. So we have here an example. In base and decimal position notation. So there are 10 decimal digits from 0 to 9. So the number 2506. So the first position is 6. Going to right, so the last position or the fourth position is 2. So we multiply it. So 2 times 10 to the third position. 3 is to 3 plus 5 times 10 raised to 2 plus 0 times 10 raised to 1 plus 6 times 10 raised to 0. So we use 10 because we use base 10. So we multiply 10 because we use base 10. Then we have different types of positional system because we depend on the position on the bases that we use. So the positional number system differ from the bases that we use. So we have different types of the positional system. So I have here only 4 because 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 most this is the most common basis that we use to compute positional system. The first, binary system. So a method of representing number that has two space and uses only the digits 0 and 1. So each successive digit represents a power of 2. So for example, 1001 represents 1 times 2 to the third power plus 0 times 2 to the second power plus 0 times 2 to the raised to 1 plus 1 times 2 raised to 0, or 16 plus 0, 0 plus 2, we came up 18. So in this case, we multiply 2. So we use 2 because it is base 2. And next is octal system. The octal system is the base 8 number system and uses the digits 0 to 7. Octal numerals can be made numerals by grouping consecutive binary digits to groups of 3. So octal system have 8 digits and the highest possible digit is 7. So next is decimal system. So in the decimal, each position starting from the right is a higher power of 10. The first position represents 10 raised to 0 equals 1 because any number that raised to that have a power of 0 is automatically equals to 1. The second position, 10, that have a power of 1 equals 10. In the third position, 10 raised to 2 times that expressed in 10 times 10 equals 100. In the fourth position, 10 raised to third power expressed in 10 times 10 times 10 or 1000 so on. So for example, 2674. So the first position is from the right, so the first position is 4, so we multiply it to 10 raised to 0. Then 7, the second position, times 10 raised to 1, then plus 6 times 10 raised to 2, plus 2 times 10 with the third power. Next is the hexadecimal system. So the hexadecimal numeral system of the shortened to hex is a numeral system of 16 symbol base 16. The standard numeral system is called decimal base 10 and uses 10 symbols 0 to 9, Hexadecimal uses the decimal numbers and 6 extra symbols or the letters A to F. A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, then F represents 15. Example 3A 8E. So for doing the process, we came up 14,990 by 16. So for more information about numeral system, please go visit our YouTube channel. Thank you and goodbye.